Hello everyone and welcome. So in this video I wanted to do a small little exercise on procedural modeling using bilinear meshes. I know the final result doesn't sound too exciting, but I promise you'll probably get away with some new techniques. So let's get into it. So within a fresh new scene, let's throw up a geocontainer and start with a box. This will be our base, and I'm gonna set the size of 2.8 on the x-axis, and I'm gonna change this to a mesh, and as you can see we will have these bilinear meshes. It's like a NURBS patch with U and V coordinates, so we can easily carve them, and you will see in a bit why we use this type of mesh. So we will do some splitting in here, splitting by normal with these labs nodes, and in this case I'm gonna split the z-axis, so both primitives on the Z, and we will work on the other parts, but for now let's focus on these primitives along the X. So I'm gonna again split based on normal the primitives along the X, and I'm just gonna blast the first one, so just the primitive 0. So in this case I'm gonna blast the primitive 0, that's it. And now what we can do is to do a carve. And as you can see, we are able to carve the geometry like if it was a NURB surface. And we can do it both on the Y, on the V component, and on the X component, the U. So let's delete this carve. And now we want to split this geometry into different sections with with a polysplit. But I want 3 divisions near the center of the surface and other 2 on the near the edges, near the ends. So for that I'm gonna use instead a curve for splitting. So bear with me, I'm gonna carve this and set this to in this case set this to 0 and do extract. Then we will have this geometry. We need to resample by density. So we have here resample by density, and we want to set some points, let's say 6, and we should be seeing our points, but yeah, it's too small, so let's go in here on guides and point marker size. Yeah, so I'm not sure how many points did I use, so in this case 6 is correct. And now, as I told you, I want these 3 points to be more near the center, and these ones further away. So for that, I'm going to create in here a point on the 0, then one at 0.15, and just mirror these along the curve. So this one 0.32, then another one at 0.5, so 0.5, and this one at 0.68, then one in here at 0.85, and this one at 0. So as you can see, we have the final result. Of course, you can play with the ramp and have a different layout, but I'm going with this one. Now, in order to read the positions to do the carving, we need some sort of attribute of the position of the points, and we can't rely on the world position. So what we can do is create a UV texture and create some UVs based on the arc length spline. So if we go to the UVs, as you can see, we have the same distribution of points along the UVs. So that's fine. Now we want to, so where is this? Yeah. So we want to carve these based on these points, and for that what we can do is create a for each number. And I'm gonna change in here the color to something like this. I'm gonna input this one, and this will just duplicate, in this case 10 times, but I want to change this to the amount of points we have on this curve. So let's create a spare input and connect this UV texture in here, and we will do for the iterations and points of the spare input -1, since we want to do one after the other on the curve. We want to do the first U and the second U. So now we should have 6 points, that's correct. And now let's do a curve. And for this curve, we want to do, in this case, it's not first U, is the first V and second V. And now what we will do, we will connect these in here. So let's connect these as a spare input to the curve. Oops, oh, not this one. So we want to create a spare input in here and connect the UV texture. And we also want to connect the for each count to know which point number we are iterating now. So let's create another spare input, and this will be -2, and it will be the for each count. Now we can simply use a point expression in here. So if we do, let's open the expression, and let's do point. We want to read a point from the first spare input, so this UV texture. The point number, we will leave it for now, and we want to read the UV component and the first component, so the U. And for the point number, we will use the iteration number, so detail -2, which is the second spare input, and we want to read the iteration. And component is just 0, and this should work. So let's copy this and paste. And now let's do the same in here, but we want to add 1 to the iteration, so we want the next point. So let's see, something is missing in here. So point, my detail, iteration 0, UV 0. So the issue is that we are reading a point attribute, but these UVs are in vertex. So let's change this to point instead. And now it should be carving, as you can see, and we have the resulting. We could do also vertex in here, but just to simplify, we can use just point, a UV attribute on points. So there we have our carving. And now we can simply convert these to polygons. So, and then fuse, because they are not fused, and we have, as you can see, 6 frames. Now we can do a poly bevel, and we will bevel by about 0.035, and we will also save in here the polygons that were generated, so edge field polygons, and we will do a poly extrude on those. So let's select those and do a poly extrude. In this case, we want to go in, so -0.03, and we also want to inset it a bit, so 0.015. That's fine, but now we have this problem where the geometry is insetting also along the z-axis, so we need to reset that. So what we can do is to go into the transform extruded front and go for global, and we will just scale along the x. So we will take 1 plus, and we will copy this inset and multiply, and let's see. So it's doing something, but we actually need to multiply it by 2. So let's do multiply it by 2. Oops. This one should go in here. And as you can see, now it's completely flat. If we look at here, it should be completely flat. So we just fixed that. So that's one part done. Now what else can we do in here? We can also clip these along the X, along the Z, I mean. So clip in off. And let's do all primitives, and let's save the clipped edges. And let's do a bevel. And we want to bevel the clipped edges. And let's say it will be about 0.035. Let's also output the polygons. Let's name these two. And let's do a poly extrude on those. So number 2. And if we extrude, we will have some problems, as you can see. So what we can do, we won't use this distance, which will move along the normal. We will do transform extruded front and translate this back, and let's scale also to 0. So we might need to move this quite a bit. So let's say 0.0, 0.1, 1.41. And there we have. And let's continue on the next part. So after this poly extrude, I want to object merge this UV texture, this curve in here after the UV texture to create those bars. And I'm gonna do a manual transform to put it in place. So we have this, and I want to move it to about, let's see, minus 0.04, minus 0.04, minus 0.4, I mean. So move it like that. And now we will carve this a bit, carve, and we will carve the first U and second U, and we will do it by about 0.04, and I'm gonna copy this in here and just say 1.0 minus the first U, and this will mirror the effect, as you can see. So that is fine. Now I'm gonna sweep this and change it to round tube, and for the size I'm gonna set it to 0.01, so radius of 0.01, and I'm gonna also output a bilinear mesh. And right now this geometry is oriented in a certain way, so the ends of the patch, but we want to do a custom orientation in here, but we will do it a bit after this. So let's do a match size for now, and let's connect these in here. So let me get more space in here, and we don't want to move this along. We want to set this to max and min to place it along the limits, and set the Y to none and the Z to none, so it stays in the same place. Let me just see something in here. So 0.01, 8 divisions is fine, bilinear mesh. And I also want to offset it just a little bit, so 0.012, so it moves a bit in. So that is fine. And now we can continue creating those attachments to the surface, to these bars. So let's do a carve, and let's start to carve. And as you can see, we can carve half of it, so let's say 0.5. But I want to move it further away, so if I do on this side, I can't go negative to wrap around. So what we can do is to go on the sweep and change this to custom and set this orientation to be -1 on the Z. And now we can easily set the values. And in this case, I'm gonna do a second U of 0.886 and copy this and do 1.0 minus the second U. Now we will have the correct carving, and then we can just do a carve along the V component. So let's set this to 0.91 and this one to 0.95, so something like that. And let's create a null just to get rid of those lines, and now we can convert these to polygons. So convert. Now we have polygons and we need to fuse, and we need to group. Now we want to extrude these edges, so for that I'm gonna group those edges, and I'm gonna do it by bounding box. So let's see, let's set these two edges Let's enable bounding regions. Bounding rectangle will be fine, but this is not centered. So what we can do is to do bounding box and get the X max. So this is along the X. So now we center it along the bounding box X max, and we will do 0.01. So just to select those. And just to be safe, we can do a centroid. So centroid 0 dy. Oops. And copy this and do, oops. Copy and do dz. We don't need to do this, but just in case. And we can also scale down, but it will be fine. Now we want to extrude this. But if we do, so let's poly extrude. And let's select those edges and extrude. So as you can see, is extruding along the primitive edge, in this case the edge normal. If we do point normal, it won't also work, so we need some custom normals in here. So let's do that quickly. So what we can do is to, let's see, we can do v at, and let's save a custom attribute underscore n, and we will set it along the z-axis. And let's multiply it, we want them mirrored, so let's do a sine of the hp dot z, but in this case the object is not centered. So what we can do is to do v at p minus equal get bounding box center, and to move it to the center. And now it's at the origin, and if we look at that attribute, let's do marker and vector. And as you can see, now we have the correct normals to extrude, but now we need to move it back. So let's do instead p, so let's do vector rest, it will be equal to v at p, and we at the end we can do v at p is equal to rest, so to move it back. And now it's at the correct place. And finally, we can extrude this using an attribute, and it will be the underscore n. And now it's extruding properly, as you can see. So let's see, let's set a distance of 0.022, and we want 5 divisions. And what else? Now we can do a simple. So in this case, I think I need to change something in here. I want to go back to the carving and set the y divisions to be about 8. So as you can see, we can go back and change things. And from this poly extrude, we will now do a simple poly bevel. So bevel. And let's bevel only those inner points by about 0.01 and set the divisions to 2. Now we can do a simple peak. Let me see how much did I use, so about 0.0002. And let's do a subdivide. But I want to round those corners, so what I can do is to change this to, so in here in the point attributes, we want to change this to sharpen edge boundaries. So something like this. And now we can do a simple thicken. And let's do on both directions, but I want a very small value, so 0.001, so something like this. And even this gives us some problems in here, but it doesn't matter. And now we will just copy this around. So let's copy this, copy and transform, and move this back, move this down by about 0.2, and we can just do a mirror. So mirror on the Y, and that is fine. Now on this side, after the match size, we can do a convert, the polygons. And we can also subdivide this a bit and do a polyfill. So subdivide and polyfill, set it to single polygon, and let's have a look at the result. So if we merge these and do a null in here, we will have the correct geometry. We did that big so it doesn't stay on the surface of the bar. And what we can do, we can copy this around. So if we do a copy in here and we want to move it along the Z by about 0.2, now we want to mirror this along the Z, and we also want to mirror this but along the X, so we have the same on the other side. Now after this poly extrude, so that we have in here, we can also mirror this, and that is fine. And let's do a merge of both these, and as you can see we have almost all of it done. Let's finish on the next part. So let's go back up and finish this. In here I'm gonna just work on one of the sides, so I'm gonna blast just the 0. Let's create a null, and we will convert these to polygons, and I'm gonna do a simple divide to create some geometry. So in this case we don't want to convert, we want to breaker, and let's do bbox, in this case along the x size, and let's divide this, let's say 20. I'm not sure how much did I use, so I used 40 in this case, and we can leave the others the same. So let's do a poly extrude. Let's extrude individual elements, and we want to extrude these, but we want all but skip every other one. So go like this, and let me see, I will use a distance of 0.03, and I'm also going to inset 0.015. And now we need to take care of that inset along the y-axis. So for that we already have done this. So let's do one, let's copy this inset, and let's do 1 plus inset, and let's multiply it by 2. Oops, not 1, by 2. And now we have that inset only along the x. Now let's match size this to the center because we will copy these 2 points. That's fine. Now let's go in here. Now let's do another split by normal. And in this case we will skip, we will just do x, and let's invert to have these ones. Let's create a normal along the primitives, and let's do extract centroid, and we will run it on primitives and make sure we transfer the normals, so this way we can copy these 2 points. So copy 2 points, and let's copy these to these points, and as you can see we have a slight offset, so what we can do is do a pick and make sure we don't recompute the normals, and we will copy this distance in here. So it is the distance, I think, yes. We will copy this distance and paste it in here, but divide it by 2, and now it should be perfect fitting. So now it's just a matter of merging this in with the rest. So let's do another merge in here. And now we just need to create in here a shape around the corners. So for that I'm gonna object merge this box, and let's say move it around here, And let's convert these to polygons. Views. And let's do a small peak of around 0.02. Let's do a sweep. Let's set these to a square tube, I think. And I'm gonna change just the width to 0.04 and columns just to 1. And if we merge these, and there we have the final container geometry model, I mean. So, as always, you can grab the source files on my Patreon alongside with exclusive tutorials. I have hours of exclusive tutorials in there and also all the project files from my videos. I really hope you enjoyed this one. Please let me know your opinions in the comments. And I guess I'll see you next time. Thank you.